Okay, so let's look at how do you solve some problems in geology. The first example is when we're going to look at apparent dips, and you will remember that apparent dips, do not represent an actual plane, so therefore they are linear features which will plot as dots on your stereonet. So we can say that we had one measurement that actually plotted over here, and we've had another measurement that plotted over here, and we would like to know what is the true dip angle and dip direction represented by these two apparent dips. Of course, these apparent dips will have to lie on a plane, okay? So you would rotate them until they fall on the same great circle. When they fall in the same great circle, you can actually draw in that great circle. Okay? Oops, I made a bit of a mistake here. See, you have to be a little careful. Okay? You have to make sure that you actually, it's a little bit difficult looking past the camera, but I think that is better. So that would be the great circle on which these two apparent dips would lie, and you can draw that in. Of course, as soon as you've drawn that in, you can of course read off the dip direction here, and you can of course also read off the dip angle. The dip direction we'll do just now, but the dip angle will be 10, 20, 30, 40, 50, 60 degrees. Okay, that's a dip angle. We rotate it back to north, and we actually read off what would be the dip direction be: 10, 20, 30, 40, 50, 2, 4. So 0, 5, 4, 60 is the true dip direction and dip angle given to us by these two apparent dip angles which you measured.